Let me describe a situation and tell me if this sounds familiar. You finish your smart contracts, they're clean, audited, tests are green. You deploy, feel like you're almost done. But then the real work starts. You need to listen to events, trigger something when a user signs up, send a notification, handle retries, and even make sure nothing breaks when the chain hiccups. And suddenly, what looked like a 2-week feature turns into a month of back-end work. What's wild is this is happening even though block times are faster than ever. In fact, Polygon processes tens of millions of transactions a day. Ethereum L2s handle more than half of all EVM traffic, and yet development still feels slow. Not because of Solidity, because of everything around it. That's what we're fixing today. Hey, I'm Steve and welcome to the EVM world, where we break down how EVM applications are actually built in production. By the end of this video, you'll see how teams are shipping EVM dApps much faster, not by rewriting contracts, but by removing the off-chain friction that quietly kills velocity. We'll go through this in 3 parts. First, why Solidity is rarely the bottleneck anymore. Second, where EVM development really slows down. And third, a live walkthrough showing how low-code workflows with Kwala replace weeks of back-end work. Let's start with the uncomfortable truth. A few years ago, writing smart contracts was the hard part, but that's changed. Today, we have solid frameworks, audits, battle-tested patterns, and much higher throughput. Polygon alone averages 60 to 70 million transactions per day, with peak days going even higher. So if execution is fast, why does building still feel slow? Because contracts don't act on their own. The moment your dApp needs to respond to something, a user registering, a swap completing, an NFT minting, you leave the EVM and enter off-chain territory. And that's where things drag. Every serious EVM dApp ends up building the same invisible system. You need something to watch events, react to them, trigger actions, retry on failures, and stay in sync across chains. This is where teams lose time. Not because it's hard conceptually, but because it's repetitive, brittle, and never quite finished. Most teams handle this with custom scripts, cron jobs, queues, and glue code. It works until it doesn't. And that's why developers end up spending 30 to 50% of their time on infrastructure no user ever sees. So the question isn't, how do I write better listeners? It's, why am I still writing listeners at all? That's where the shift happens. Let me show you what this looks like in practice. We're going to build a complete new user onboarding flow end-to-end, front-end, smart contract, and off-chain automation using Kwala. By the end of this video, you'll see how all 3 pieces connect without writing custom backend code. Step 1, the smart contract. We'll start with a simple contract. All it does is accept user registration data, store it on-chain, and emit an event called record saved. Nothing fancy here. This is exactly the kind of contract you'd already be comfortable writing. The key is the event. That's what we'll react to. Step 2, the front end. Next, the front end. We collect the user's name, their Telegram chat ID, and their wallet address. When the user clicks register, the front end connects the wallet, calls the smart contract, and sends the user data on-chain. At this point, most teams would start building back-end logic. Instead, we stop here. Step 3, creating the workflow in Kwala. Now let's move to Kwala. I'll create a new workflow and call it new user onboarding. For the trigger, we listen to a smart contract event on Polygon Alloy, specifically the record saved event. This workflow runs every time that event fires. No polling, no custom indexer, just a declarative trigger. Step 4, adding the action. Next, we add an action. In this case, we want to send a Telegram notification. So we configure a post request with the Telegram API and pass the user data from the event into the message payload. That's it. We compile the workflow, deploy it, activate it. Step 5, testing the flow. Now let's test it. We go back to the registration page, connect MetaMask, enter the user details, submit the form. The transaction confirms, and you can see the hash on Polyscan, and the data is stored on-chain. And a few seconds later, the user receives a Telegram message. No backend server, no retry logic written by hand, no script running in the background. The workflow just works. This is the real shift in EVM development. not smarter contracts, but smarter systems around them. If this was useful, subscribe to our channel and stay tuned for more insights around the EVM space, and I'll see you in the next one.
Also, if you want to ship a complete Web3 onboarding flow in minutes, all on your own, click the link in the description below to watch the full demo video.